Got a nice little equation here, and it happens to be r is equal to 6 cosine theta, and we need to change that to a rectangular equation. What I'm going to do is I'm going to offer you some suggestions here, but we're actually going to go through what a student might do and how this might not work for you. So r is equal to 6 cosine theta. Some students right away would take this r out and then try to change that out for the square root of x squared plus y squared, and that's equal to 6 cosine theta. The problem with this method, even if we square each side, is that we haven't changed out this theta here. So we've done a nice job getting rid of the r, but the theta is still there. So instead of doing this, and you're gonna make these mistakes, you're gonna try something that's not gonna work. It's okay, just go back and try something else. So we tried getting r by itself, or r is solved for. It's already solved for, and we tried changing it out for something that it's equal to. It just didn't work this time. So one of the other tricks, or the hints I should say, in solving these is to multiply by r on each side. So if we multiply by r, we're going to have r squared, r times r, and then 6r cosine theta if we just multiply by r on each side. Now we can change this out, and this will be just x squared plus y squared. We don't want the square root there. And then now we've got this guy, r cosine theta, which we can change out for 6x. Now this is okay as an answer. This is fine. If you really wanted to, you could also take this equation. We'll subtract 6x here, and we'll keep the y squared, and that'll be equal to 0 if we subtract 6x from each side. We need to complete the square here. So half of negative 6 is negative 3, squared is 9. And if we add 9 to the left, we've got to add 9 to the right, so 0 plus 9 would be right here. We could factor this into x minus 3 squared plus y squared is equal to 9. This also works. This would be in standard form if you were asked to write the standard form rectangular equation for a circle. So this circle has a center at 3, 0, and a radius of 3. And that would allow you to take this polar equation, change it into rectangular, and then perhaps even graph it. This guy over here is totally in rectangular, but it's just not easy to graph this one. So either one is okay for what we're doing here. And then if you're looking for a little bit of something extra to do to change this into standard form, well, there you have it.